to speed.
Yeah. Okay. I just started it, and I'll put that up on our YouTube channel. We have all the recordings from all the meetings and stuff, so that people who want to catch up can. And
Cool.
so you'll find that on the UB Sports channel.
Very good.
I'll
By the
send.
way, cool glasses. I like those.
Yeah, I've been my ex-girlfriend liked them, so I got them because she wanted me to
Yeah.
have cool glasses.
And when you migrate to AR smart glasses, they'll be right on.
Yeah, I know. They'll put right here, and we'll be good. Yeah, I'm psyched about that. I'm really psyched about this whole generation of technology.
Me
Really
too,
good.
man.
Have you
I've
played
never
with any
looked
of the
forward to
VR?
glasses before, but
Yeah, I know exactly. I'm just the opposite. I want to get rid of the glasses.
yeah.
But yeah, have you played with VR much?
I have, mostly just for fun, but
Yeah,
we did
me
one
too.
project in it about a year and a half ago. And I do sim racing a lot,
Huh? That's
I used to
cool.
race. I used to go to Bridgehampton and Lime Rock and stuff, not professionally, just, fun. But that
Sure.
was years ago. And then I got diagnosed with lupus. So my reactions, I don't trust myself anymore,
Huh?
and this is safe,
Definitely. That's the great part about it. They had some whole race a couple weeks ago. Was it Lime Rock or one of those places? And it was all technology. It was all computers.
It's going to be cool. I love the sound of big, petrol burning, whatever.
Yeah, of
But I
course.
also love the immediacy of electrical, like the hybrid, what's going on with E, the
Yeah.
conversion, Formula
Huh?
E and all that.
Yeah.
Right now it's kind of, they're fooling around. They're trying to figure it out. But I do like the idea that people can actually remotely have a hand in it,
Yeah.
They've got to scale it, so we're not talking about multi-million-dollar vehicles. We got to
Right.
have a whole range, but I think converging virtual with, in real life, it's going to bring in new types of enthusiasts,
Oh, it definitely is. It is a whole new world, and it's wonderful they can do it now. That they can actually have that kind of computing where you can have 30 cars racing around a NASCAR track, and it's all technology.
Yep.
It's just amazing.
And it's gotten good. It really has, I mean,
After about 10 minutes, it's like the real thing.
Your brain fills in what isn't there,
Yeah.
And the one thing that I do like that I'm just going to add sometime with some linear motors is rear end slip, when your rear starts to come out on you a little bit, because that's real important feedback, I don't care so much about the forward back and all that, but
Right.
to be able to not just with your eyes when like minor degrees of slippage are happening, but literally feel it under your butt, I think that'll be real helpful.
That's
Looking
really
forward to that,
cool. So how do you have a whole setup? Do you have a steering wheel and the pedals and everything? And
Yeah, I actually, the way it started was I was contacted by somebody from out in Long Island that did some work, brake pads, this stuff and the other. It was from Alex Borla Mufflers.
oh yeah, I've heard about them.
He sold out to some other company that was more broad-based, and they manufactured, all these exotic carbon, Aramis fiber, whatever stuff. And they had a customer that they had done development with in Germany, Bosch. And
Yeah.
Bosch with ABS was losing potentially a lot of big customers because the anti-slip technology has advanced tremendously. And ABS, except in certain limited instances, was actually causing more problems than it was solving.
Really?
So,
Wow. I didn't know that.
yeah, especially in variable situations where the real differential and slip was a lot, or if you're going around a turn, or if you went over a segment of pavement when you were slipping and then regained.
Right.
So I did an AI project for them initially as a proof of concept.
Wow.
And to show them that without totally re-engineering, we could have a mode that is actually learned from a huge amount of data, the telemetry of various cars. And we simulated like 15,000 cars, just a proof of concept, right? Going around the track in different conditions and stuff. And they liked where it was going. So we took the next step and we actually re-engineered ABS. And along the way, I needed to be able to, get involved more. So I set up I've got a whole freaking rig thing. It's not one of those like you've seen where it's up off the ground and all.
Right.
They have one of those and a lot of car makers do. This is actually on the ground, and it has vibrational feedback, but it doesn't have the motion feedback.
Right.
But I've got wraparound, you've seen those things.
Sure.
So it's a pretty good setup.
That's awesome.
Yeah, and it was a lot of fun. It was a cool project.
It amazes me the stuff that you get involved in. It's just incredible.
Yeah. I've said to people, like, sometimes people ask you, like, what kind of things would you not do like you did, and what have you learned, right? And one of the things I did for a long time was whatever came in the door, right? Especially that was my project. And as I had bandwidth, I took on things, and when I didn't, I didn't. And I didn't go out, I didn't actively market, I didn't reach out for certain sectors. I got no reusability pretty much of past projects to a large extent,
right.
except in some situations. But I got to do a lot of different shit, That was the good part.
That's awesome.
So pros and cons, but if you were trying to do it and build a big business and, sell it off at some point with, dozens or hundreds of employees, that's not the way to do it. But
right.
if you want to get like dabble in a lot of things and become a master of none.
That's you, right?
Good. That's me.
Yeah, right. Sure. Okay, so I guess we have the guys on who are going to be on.
Excellent.
They're muted and they're not showing their pictures, but they're there. I have Karl Kirchhoff, who is from Germany. He was actually involved in. Okay, you got Bill Clark. That's Bill driving around. And that's it. Bill, meet Andrew.
Hi, Bill.
Good afternoon. I was on mute because it's 9 p.m. here in Germany and I needed to put my son into bed.
Oh, hi, Carl. How you doing?
What's that?
Go ahead, Andrew.
So, where are you in Germany about, Bill?
Currently stuck in Hamburg.
Oh, Hamburger. I have some good friends from Sindelfingen, around Stuttgart.
Right.
And I miss Germany. I absolutely loved it. And I got
I'm sure more than ever now.
Oh, yeah. Very special place. You're very lucky.
Where are you guys?
I'm in a place called Prescott, Arizona, which is about an hour and a half north of Phoenix. But interestingly, we're at about a mile high like Denver. But our weather is, we get about 300 days a year of sunshine, so we don't get enough rain, maybe 14, 15 inches a year. But what we do get is a lot of really nice, clean air. It's great for outdoors people who like to bike or hike or whatever. But an hour and a half one way, it's typically 25 to 40 degrees warmer in Phoenix. And an hour and a half the other way, we get to about 8,000 to 11,000 feet in Flagstaff, where it's about 15 degrees cooler. So it's kind of neat. It's a neat place.
I remember I was living in the United States for 10 years before November 16.
And you enjoyed it for the most part?
Absolutely, yes. And then November 16 changed everything.
Oh, wonderful. Yeah. I enjoyed most of living here for most of the years, but what place is perfect?
Sure. I know you have good golf courses.
Oh, yeah, that's for sure.
Yeah.
Yep.
That's true.
Definitely.
And but you're looking at Bill also. Bill works with NBC right now in their video area.
Very cool.
Hey, how's it going, guys?
Hey, Bill. Nice to meet you.
Nice meeting you too. I heard so much about you now, and I'm curious.
You on Long Island now, or?
No, I live in down in the South Jersey area, Lincroft area, New Jersey.
Cool. Yeah, the last of my family.
Babylon.
Yep. They live in New Jersey now. My cousins and stuff.
Wow.
So I only get there on occasion, but.
Yeah.
Yep.
Well, Arizona. Why would you want to leave?
Yeah, well, I loved Long Island, but it's like I don't know if you know the song Sunscreen, whatever it's called, Better Wear Sunscreen, but it goes through all these different places, like live in California for a few years, but don't live there too long or you get too soft. Live in New
Right.
York for a while, enjoy it, but don't live there too long or you get too hard, you know? And Arizona, I happened to come out because of some very nice people that needed help with a website that was a tiger by the tail for them, like a really nice mom pop kettle type that were what would you call them, Christian Baptist, and they
Okay.
thought, you know, what should I this internet thing? Maybe it'd be good to get involved. This was back in the mid '90s. What would be maybe, I don't know, Bible.com, and they typed it and it was available. So it started to go, you know, thousands, tens of thousands, millions, tens of millions, and they just basically, it wasn't, you had to co-locate your own servers at that time, you know, and you had to
Right.
have your own people that were like, you know, you didn't have a lot of the things we take for granted now.
Right.
So
True.
I came out, I fell in love with them. They kind of adopted my now wife and me, and we all became really good friends and we helped them out. So they live right around here within about 30 minutes of where I live now. And they
Oh,
were my
nice.
introduction. So,
Very nice.
yeah.
Yeah, I was born and raised in the Bronx, and I still work in the city. See there, but I live out here, so I kind of get away from the craziness when I'm in the city. I come home, relax, nice and quiet, to recharge my
Smart.
batteries that way, you know.
Yeah, yeah, you'll live longer and happier.
That's for sure.
At least that's the theory, right?
Yeah, yeah, on a good day.
So a little bit, let's, I guess we're not going to see the other one or two guys that we were expecting. We're expecting Tony and Frank, and they didn't show up. So let's just, you know, kick it off and see where we can go. First of all, a little bit about UB Sports and why we're talking to Andrew. Andrew, I think, how many years? 8 years, 10 years we've known each other?
At least 10.
Yeah. Yeah. And we've always been thinking about maybe working together on video and bringing out some really good products for the sports area. And we're finally getting around to the point where it looks like we're about to get funded. And I also was, if for that stuff, we'd want a regular video system, and that would be good for both the web and also for mobile. But then there's this organization in Europe called Hype Sports Innovation, and they do incubators for different sports entities, and they also invest in A rounds and B rounds of successful sports companies. So I happened to have stumbled upon their esports incubator. Mm-hmm. And they asked us to apply for it. They already want to buy our whole A round. So that's really exciting because I know, you know, instead of a bridge, instead of a pier, it's a bridge. So this money here is going to get to an end game. And that's what's really exciting about that. But they also said, we have this esports incubator you should try out for, because it's video and it's sports and it's something that is really cutting edge. So we were talking to them, and they said, the problem right now is that there's some good technology for the web, but there's no kick-ass technology for phones, for mobile. And, you know, you can't really compete well on mobile in an esports situation. And they still have a lot of lag in regular esports on the web when you're on your PC. So what, you know, I wanted to do is talk to you about what we can do now to present a better technology package than what they have now. Package it so that we become the leader, because everybody else's legacy systems, everyone else's computers are 5 years old and 10 years old, and we're going to be right there on the cutting edge. So I wanted to really make sure that we have a stack that is going to kick butt, that is by far the best technology. No one can say, well, ours is a little bit better here or there. I want to say we have the best technology, the fastest technology, the least lag, the least latency. And this is why you should be working with UB Sports on esports. Yep. So that's where I want to start. But then you started talking last week when we were talking about AI and quantum computing. And now we're thinking, you know, if we're the test bed for that as well, these guys will have no choice but to work with us. And that's where I want to be.
Greg, just a moment. I'm going to turn this off and go on my computer. So I'll be right on.
Okay. And hurry up.
So have you gotten out and done any sailing lately?
Not this year. We're going to kick it off. Well, unfortunately, you can't do big boats because we can't be close to each other yet because of COVID.
Yep.
But we're doing individual lasers, the 12-foot boats. We're going to start doing that in the next week or so. And from then I'll go right through the season every Friday night. So
That's awesome.
it's so much fun. I'm waiting to have a wetsuit delivered because it's just a little too cold to be out there. I started racing last June on the boats. And the first time out was the first time out in 10 years on a laser. And they're very tippy boats. And, they only weigh like 60 pounds each. So it can be a little interesting. So the first day, it's June 15th or something like that. I tipped over, went in the water, and I was surprised it wasn't that cold. I was ready to freeze my tail off, but it wasn't that bad. So we did okay. And but yeah, I'm ready to go. This is going to be a good year for that kind of stuff. Except with this funding, I'm going to be working 24/7.
I know. Yep.
And that I want to. That's a good trade-off.
Yeah.
Going,
Yeah, I know. I mean, the first company that we ever did like some significant funding for was a web company. And I had plans, like, hey, we're going to work hard, but then we'll take a break, I'll get a week away after No, it was like 2 years, before we even took a vacation of any sort,
Yeah.
But for the most part, you look back and you say it's worth it. So
yeah,
you just can't go too long that way because it'll hurt you.
Well, I've committed to 5 years of 24/7 pounding this out, and it's like full on sprint.
Yep.
So I'm really good with that. I'm psyched. And
yeah, well, you're in good shape and everything, and you're used to the game.
Yeah, well, I've been really planning for this and gearing for it for years. So now that it's there, we're ready to go. Very excited.
Very cool.
So tell us first about like what you see right now is what we should be doing to set up, the levels of, where CDN, everything else, technologies.
Yeah, I did a little bit of looking into that, and I'm waiting to hear back from one guy that I had done some work with some years back who really knew his stuff. He's one of the contributors to some of the big CDN reviewers. So he's a journalist and an editor and a technologist and so forth. Anyway, he said he would get back to me within a day or two, so hopefully I'll hear from him. I did the rounds of looking at the available CDNs and infrastructure. And there's two things. One, a matter of scaling and scalability. That kind of breeds a lot of people towards the one-size-fits-all solutions. And there's a lot of them out there. The problems with them are latency.
Right.
And second, you have no control over a lot of the core protocols. So if you want to do stuff that's like outside of what you're going to get within the AWS infrastructure, of which it lets you do a lot from a business and a data collection standpoint, very little from an actual architecture optimization standpoint. So it's got its strengths and it's got its weaknesses. I think those infrastructures, especially when you cut a good scaling deal and you set up your infrastructure right, can be a good boon to the bottom line in terms of your cost. So from an alpha standpoint, it's definitely a useful part of the mix. But a lot of companies, and this amazes me, and it's kind of like not just in media, like I'm just finishing up a white paper related to something to do with basically text to speech and speech to text and natural language and so forth. And you would think that the Googles of the world and the Amazons would be using leading edge technology in that. And surprisingly, no, they're actually using 5, 6, 7, 8-year-old stuff. And they look at it as a necessary part of their infrastructure, but they put most of their resources actually in Google's instance into the video closed captioning speech to text. And that's about as close as they get to approaching anywhere even near state of the art. So it's the nimble companies that say, look, we're starting with a tabula rasa. We don't have to go one direction versus another. What do we need? What do we want? What is worth doing better? Or what should we leave to a second stage or whatever? So you have a lot more latitude, and it's good you're looking at that. I do believe that you need depending upon what you want to bring in-house versus what you want to subcontract and leave out there as just service provision. I'm a big believer in reducing risks, time to market risk and all of that up front, but getting there with something, and I'm sure you've given this 10 times more thought. I'm probably speaking the obvious to you, but getting to the market quickly with something special. And sure, it doesn't have all of the great things that you'd want, but that's what 2.0 is for, 1.5 preferably. So I think the big infrastructure providers, you do want to, for the on-demand rather than the live stuff, they're really bad at the live. All of the times and all of the QoS stuff that I've seen, anybody who's getting realistic QoS is setting up their own, Wowza or other complex, basically their own streaming plant. And the reason for it is the infrastructure that they have is just not tunable to any realistic extent. The second part of it, from a player standpoint, there's some really good tools out there, and they're actually open architecture. JW for a long time, JW Player and all of that. Good stuff, good people. They actually do specialty consulting still. And they have a group that understands the ins and outs of both the existing infrastructure providers, in terms of what's turnkey, and also what they would do if they had their druthers. And as of about a month ago, there was a project I was reading about that they were doing some really cool stuff for some people. So I think that would be something I would definitely look into, because believe it or not, it's not all server side. That stack is critical, no doubt about it, but it's also about how you handle the fact that you've got a variable CPU, GPU, and quality of service that varies the most at the periphery, i.e. on the user's platform. So that's a big mistake that I agree with them totally, that is often overlooked. The difference for me of one site versus another for video oftentimes is what is the interface experience, right? Can I jump around? Does it freaking thing, if I try to go to another place within the video, it'd make me wait 10 seconds. And you'd think that all of that would be licked by now. But, a lot of companies, it's a matter of delivering a product rather than delivering a great experience, surprises me. So from a top level, what I would say, what we could do is put together kind of like for the given stage, the given rollout.
It's also very cost
Go for it.
to not go bigger. I understand why companies do that. On the side, I like to better quality.
You're breaking up a little bit. Can you say that again? I'm sorry.
So most companies don't also increase their system speed and processing speed and everything else, or else it costs too much money for them and their little budget they have. But I'm a proponent of quality over the cost.
Yep, totally.
I think it can be cost effective, still can get better quality for the money.
Yep. Well, look at this, for example, with Zoom, right? Like, I can't tell you, I would say every other call has what I would say completely disruptive experience at some of the stages. And you say, well, it's the end user. They can't control their bandwidth, and maybe they turn on a microwave oven. Sure, there's some catastrophic things, but a lot of it is just because they don't do anything that's intelligent. They don't do anything that's adaptive. It's one size fits all. And they make assumptions which are often not valid. I know they're not valid if you're moving around much, even in a park, let alone in a car, And it's all addressable, It's like you look back and the things that, my dad's generation, when you look back at how they solved problems in the military, or you look back at like in the early days in the trenches of multimedia, the shit that I dealt with, you kind of like, it was always what we call the hell of things not working. At the very least, not working the way you'd like them to. But it was all about writing optimized approaches to work around infrastructure issues. And it's kind of like they've gotten away. Everything is such a high level, rapid development tool set whether it's, full stack development tools or, even website stuff, right? And there's a place for everything, or most of these, whether it's WordPress or Amazon Web Services or what have you. But when you're trying to compete in a marketplace, especially if you're dealing with things where acquisition is happening oftentimes in highly uncontrolled environments, i.e. out in the field. I know that NBC, they have media departments, they have multimedia development, and they have some really good consulting teams that they've worked with on the outside. Almost all of the big boys have. I know how for this year, for the Olympics, which, is what it is, but they were getting all set for, augmented and virtual reality overlays to all of the sporting events and how that was going to happen, and to do collaborative, shared environments and all this stuff. So, they are pushing the fringes, So it's kind of nice to see. It's not just the porn sites that are pushing the fringes anymore. But
Yeah,
I think
the company, NBC.
Yep.
NBC does that. That's right.
Yep.
They like to be the cutting edge.
And it's great to see it, because they'll take it in different areas and different directions, and it does spin down. People wind up reverse engineering what the big companies have done. They learn from it. They create tools that are now open source. Kind of reminds me of the early days of the internet, when it was kind of the Wild West, and that people were very open. It was very, even though it was corporate and becoming more so, there was a lot of shared knowledge. And that's happening tremendously, especially with AI, and even more so with quantum computing. Not on the hardware side, but on the integration and on the development and software and so forth sides. So we have a great day and age to kind of take things to the next stage. So from an optimization standpoint, Wowza, and there's some other companies too. Wowza they had an open platform called Red, and then they had their for fee and so forth. You also, and we did this several years back, it's actually been a bunch of years now, about 9 years. We had created a collaborative conferencing environment that was ultra low latency. It was designed to allow you to kind of like do what you do with Skype or Zoom. But it was meant like real-time screen sharing, where if you had video playing on your computer, it was playing whatever the frame rate was to everybody else's. And we used protocols that were designed to scale. So they didn't scale as a squared function like all these others do. You had 1 million users. All you needed at the bottleneck point was about 400 streams worth of bandwidth. So anyway, now what you can do with AI, and Google's doing this, Microsoft is in the game, I told you a little bit about it, what they're calling zero latency, negative latency, and so forth. It's designed, it's not truly negative latency, it can't be, but it's predictive and adaptive. So the idea is that even in complex gameplay where there's a lot of components, some of which are high bandwidth, some of which are little pieces of data that have to all be synchronized and fly around at some sort of projectable, definable rate. So it has to be deterministic is what they call it. It has to be bounded, but within those bounds, they're able to get down to about 100 milliseconds latency for gameplay. Now they're pushing it down towards 20 milliseconds and below. That is doable right here and now without all the bells and whistles of what they're doing by writing a little broadcast stack that's based on something called Node.js. That's how we did it 10 years ago. You can do it even more easily now. And what it allows you to do is, Node.js was developed by a guy who was a PhD candidate at the time. And he wanted to have something that was really streamlined, that all it did is execute from the top to the bottom with what they call no wait states. So there wasn't like every other language, like you always have like waiting for human interrupt, i.e. the keyboard, waiting to fetch data from a database, and there's a loop happening. You have to write to it differently with Node.js, which makes it kludgy for some things. Like you wouldn't want to write a complete full stack application in it. Not that you couldn't, but there's better languages. But it's great for when you have to store effectively information and or fetch it and spit it out there. Because with video or anything that's, you know, one with the clock, isochronous, whatever you want to call it, that you have the realization that if you don't get that packet out at that point, you don't want it resent later, right? So that would put it out of order. What you want is best efforts with the most possible efficiency to get every packet out to the pipe. And from that point on, obviously, there's other considerations. So what it allowed us to do was, like, I don't know what it was, 10 years ago, whatever the processors were, we were literally 15 countries on the first day that we decided, against my recommendations. I had just gotten the collaborative screen sharing to work, but I hadn't even shown it to the guys in the US that were then talking to all the funding people around the different places in the world. And they said, oh yeah, by the way, Andy has some. And I said, yeah, but we haven't. Oh no, it's okay, just show it. And it happened to work. We got very lucky. But the thing that amazed me, because we hadn't benchmarked or anything, the only thing is we had written it in Node.js. And right from the get-go, whatever was on the person sharing their screen, you saw it. If it was 15 frames a second, you saw it. 60 frames a second, it went out as that rate. So whatever your screen on the user side was capable of, it was getting it. And obviously, we didn't write our own codecs, but everything about it that was done was just a function of Node.js when it came to efficiency. So I would say very strongly, for the parts that are speed critical on both the, there's certain levels of the stack, and we can go through all the geek speak at a later time, but those things could really be nicely handled by an environment that was optimized based on that. There are other people who have written proprietary elements of that, which are highly optimized in other environments, including platform-specific ones. Those are great. You know, like they'll write effectively to the lowest level of what's called metal on the Mac side, and using various GPU calls based on each platform. But that is so much overhead and so much development cost that you can get 95% of the capabilities and ubiquity by just writing in the right architecture. So anyway, that's some of the, you know, for what it's worth type of stuff on the performance side. On the growth side, because you need the ability to scale, there's some really good infrastructure provision stuff, and it's written to almost every platform now, from Azure, you know, to the AWS open architecture, to, let's see, what was the other big one that they did recently? It was sourced to basically be on any Linux flavor and any Windows box flavor. So you can effectively, what it does, it's meant to administer control for optimum ROI to each platform based on QoS. So it's the kind of stuff that a company like NBC will write themselves, or any big company will put the $1 million+ into it. That's whatever it's worth to those companies. The return on investment isn't there for most startups. So the fact that these kind of tools have come about, and there's a few of them out there, which I can give you a listing of them as we whatever. But what it does is it allows you to adaptively stay on top of what optimizations you can make and still stay within the boundaries of what your performance requirements are, optimal, minimal, you know, all of that stuff, without getting into a lot of proprietary development. Before, we used to do that kind of stuff, and like I got called in to like do a couple of parts of systems like that, and every one of them was a one-off. They were all freaking completely custom. So anyway, it's a big enough industry now with all of the vloggers, bloggers, and multi-platform deployment companies, you know, where it's not just about being a YouTuber. You got to be out there across social media. You got to be able to do stuff in the field. And sure, you have certain things that'll make it a little bit easier, you know, Wirecast, OBS, whatever. All those things are wonderful. But how do you manage it as a company? And how do you keep both the cost projection control stuff and the performance optimization, because some things, based on demand, you want to push them out to lower cost archive storage where it's still on demand, but it costs you 5 cents on the dollar, right? So all of that, I would say that's another consideration. So overall, Greg knows I'm a big believer in something that IBM created in the early 80s called the JAD process, which is just, it's a fancy name for optimal communications for project management, where before JAD, and a lot of companies still don't do JAD, especially smaller consultancies, it's best efforts. And before they had JAD, IBM was seeing the same thing everybody else was, that was doing consulting to corporate, military, government, whatever in between, that they were having a failure to deliver on one or more critical deliverables over 95% of the time. And, that's pretty amazing to me, but you still see it. I mean, a lot of consulting groups are called in to fix the dangling critical things from some other group that chose a bad platform or implemented something in a non-optimal way or did one thing or another, most of which can be avoided. So what happened with JAD is that it changed it from that percentage to over a 97% of consistent deliverables across all performance and deliverables metrics. And it's, it's part of the whole Kaizen, all of the optimized, how do you keep the communications efficient, not document heavy, like anytime you do a military project, it's stacks and stacks. How do you make it so it works across a wide range of small, medium, and large projects? So anyway, just a fancy name for like making sure you get all the things right up front from an architectural standpoint, and then implement and get things moving in the direction you need them to by good communications that are consistent with proper sign-offs. It's all the problems we've all seen in everything to do with casual life to business and whatever. It's usually because of improper or insufficient communications. And so anyway, that's JAD. So I would say you want to have a good wrapper around it. You naturally do that. I know you've done that in the way that you do things just generally. And I found that's critical, especially in something like this. Chances are it's not going to be a turnkey singular group that does it all, especially in the medium and longer term. So you have inside players, you have outside players, you have a consulting group, you have infrastructure providers. And it's a lot of moving parts that are, they may not all change highly frequently, but they do all change. So as you're going along, all of the things which normally get things in hot water in terms of deliverables, that's a critical thing, because they can always be addressed, but usually it's a matter of a lot of wasted time and cost doing it. Right.
Okay. So you mentioned JW has their own specialty consulting group. Is that, are we going to approach them directly, or how do we go about doing this?
I made a phone call to them because I actually hadn't talked with any of those guys for a while. And when we talked the other day, I spoke to one of the, I guess he is sales and support. And I asked him, I said, look, I talked with this guy, that guy before, and I understand, I just read about how do we move forward with that? And he said, oh, let me just get your name, number. I will get back to you. So if you want, I can just hand them over to you and you can see where they're at. But at least as of fairly recently, they were doing that. And they have some of the best people on the player side.
So if I'm going to have sorry, Bill?
Good. Yeah?
My toes right now. I think we're gonna might as well order some Evans tonight.
Okay. Evans, that's not
Yeah.
familiar.
And then
What is
I
that?
also went into the our class listing that we're working with, and I added.
Okay, Bill, I'm muting you.
Okay. And then, come on, the conference call. It's not working well downstairs.
Yeah.
I have to come out here with my phone. Yeah, thank you.
Okay, I just muted
These
him.
are always fun.
I know, it's sort of scary sometimes. So Andrew, back to now. What would if we're going to do this, we're going to need someone to be like the lead on this development effort. And so my question to you is, is that something like, how do we do this? Do we find somebody like you who's just like, obviously proficient in everything and putting it all together, or what do we do there?
Yeah, I would say where I could, and our group could possibly help with some of that is on identifying the right people, because that's one person you want to have, especially when you have funding in-house, right? You want somebody, one, long-term, that has a long-term buy-in on it, and somebody who, yeah, of course, not everybody can know everything, but somebody who's able to know enough to know what they don't know, which that's a lot to ask, right? So you need somebody, typically I've found at least in the 30s. I have come across some of these guys that are freaking whiz bang in their early to mid 20s. You may have to just look a little bit harder, but that tends to also be, a good ROI, that they become more educated over time and they adapt with you. And that's great. So your advantage on finding those people, we can help you vet, and on the process of ramping up, getting the right components. I see where maybe we can help is the two things. One, on helping with suggestion of an optimized architecture from like the moving parts and what to consider. And then discussing with the person who's hopefully going to become your internal IT person. Because at some point you'll have a project management, strategic management person, right? Because it's an ongoing effort. You're going to be an infrastructure provider, albeit a parallel one. So you have all those moving parts. You're going to need that. So to help get that initially defined and get the person who's the initial kickoff person to have buy-in, and to, if they've got other ideas, which may be better, great, have that dialogue, but make sure it's very well defined before you start jumping forward with the development. There's always a tendency. I mean, I can't tell you how many projects, especially the military stuff, where they just want to see immediate, right out of the gate, right? Even though they're used to things running billions over budget and taking years longer, they still make the same mistakes over and over again because there's so much high stakes politics and bullshit involved. With something like this, you've got at least 3 or 4 weeks of defining the architecture of what it should be. And that's both the technical and the business infrastructure to wrap around it. And that doesn't mean you have everything completely defined, but you've got it black boxed out, and the critical things for 1.0 are well defined. So that includes, tools and technologies, third-party infrastructure provision, all of the obvious things, right, that are necessary to do your initial rollout. The second part of that we could help with is the blue sky elements of it. So like you're leading out with things which will be better than the various companies in these ways. You're going to be in control of elements of your stack, which will provide lower latency, better QoS, and the ability to have functionality which is not kludgy like freaking even Zoom is, right? It just blows me away. Zoom has like 2,600 developers, something like that, and this is what we have on a regular basis. And if you look into, like, there's been research done into their stack, it hasn't changed for almost 2.5 years.
Right.
I mean, so it's not a surprise. Now they're looking at it because they're getting so much, pressure on it, and it's so inefficient that they're going to have to re-architect it. But that, to me, that should have happened a lot longer before they started adding, bells and whistles to the system. Anyway, so on the blue sky portion of it, I think it's one, AI from a optimization standpoint, and I'm not just talking about the packet delivery and so forth, but also from a user management and an interface management standpoint. There's so much that is just done. Let me step back. Almost all the tools that we have up to this point in time, they've competed on features, right? So whether it's Microsoft Word versus whatever, or Premiere versus DaVinci Resolve, it's pretty much, for the most part, it's like, all right, can it do this? Can it do that? Meanwhile, most people use less than 4% of the features in an average application. And there's tremendous overlap, right? You know, it's the Pareto's law or whatever. You know, 80% of the people use whatever percentage of the feature 80% of the time. And that's pretty much what it evolves to. AI is, from a workflow optimization standpoint, an interface optimization standpoint, and from a packet delivery and consumption standpoint. There's great work going on in each one of those areas. So for example, from an end user, what do they care about? Well, I'll give this as an example with Zoom, that when you're speaking, that audio is never jumbled. Unless you're dropping the connection, that you should have, even if it's missing the, you know, they've had to constrain the sample rate tremendously. They never do that. It's always the same sample rate. It's always the same balls to the walls, and it either fails or gets through, and they don't adapt. The only thing they finally started to do, all of them, in the past 6 years, is dropping frames. And great, okay, that's a start. But even on the frames dropping, they still, before it even makes sense to start trying to up the frames, they're constantly, there's no adaptiveness, there's no intelligence. They keep doing that, and then the audio suffers again. So your audio starts to come back a little bit, and it fades out. If you were a human being working at the speed of electrons in the middle of it, you would do it better. And that's exactly what AI does. Effectively, it's not general artificial intelligence yet. It's vertical, it's specialized. Whatever you develop can be really good at a given game, at a given thing, but it's pretty much, for the most part, a one-trick pony. So you train it on its base ability. From a packet management and an interface feedback, which in that instance would be audio-visual, that is something where there's so much data that it should only get better during the conversation. It should, unless somebody turns on a microwave and it's wiping out their signal or something. And even then, I don't know if you noticed, but when one person starts to have audio problems, oftentimes the available resources on the server side, which is very little, starts to get overwhelmed. And everybody starts, or the people that are near the borders start getting swamped as well. So anyway, it's not rocket science, but it is something that can be considered and can give you some blue sky advantages. And you could demo that way pre-initial rollout, so that if you stage funding, or if you want to be in a stronger position for your next, tier, mezzanine, however you're going to define it, that you basically give away less of the company. You've been through this process. I'd been through this process. Oftentimes in the early days, there was no blue sky. It was just getting something freaking out, right?
Yeah.
Now the blue sky is, we're at a point, I don't know if you've seen the numbers, but AI is projected now to be about a $15 trillion industry by the end of 2022. Wow. So it's, worldwide, because it's not a monolithic industry. It's, before with the internet, it was chicken and egg. All right, great. Who's going to use it? How are we going to monetize it? It was kind of that. Same thing with PCs when they first rolled out. The digital revolution was kind of like, all right, well, hobbyists, I guess, early adopters, whatever. And they knew over time it was going to grow. But up until the mid 90s or late 90s, you couldn't even say whether there was a business ROI statement to be made, right? So it took a long time for it to really get to that point. AI is kind of the first time in our lives, and we've seen a lot of these revolutions, the internet and the early days of all this great stuff. There's multiple multi-billion-dollar markets that all previously only competed on feature sets and little incremental stuff, where AI can slot into all of them, whether it's Bosch with braking to freaking everything on our computers. Any computer you buy nowadays has AI processing capabilities built into it. Our phones, everything. And the software side is where most of the strides are going to be made, albeit the hardware is having to, up its game to sort of be ready for it. But I think that's the exciting part, is that from an AI standpoint, a lot of times what you train on, there's a statement that data is the new oil. The second benefit that you get out of it is as you're training your system to provide optimal capabilities, you might just well find that you put a wrapper on that for video on demand companies, and you make billions of dollars licensing out that data enabled intelligence. And that's what a lot of these universities like Stanford, we work with them, and Carnegie Mellon, and the amount of money, they were all alumni funded before. And now they're doing amazing stuff. And it's nice to see it. And these new models, which MIT is actually lagging. I don't know if you follow any of this stuff, but the Media Lab, which in the early days when I was in high school, we kind of had this time-sharing AP thing where we kicked off what became the MIT Media Lab. And at that time, we didn't even have a person to head it up. So after we left and got the initial machines, they hired on a great guy for many years who finally moved on a couple of years ago, Nicholas Negroponte. And he basically said, what we're going to do is we're going to be able to take the high risks and have all the specialists for all of these companies in the Boston area. When they need to have answers to their tech problems, we will be their consultancy. And that's kind of what they did. And they got, apprenticeship skills delivered to the kids, the students. The grad students got real world management and tech teams out of it. And they all got mad skills. And they helped a lot of companies, obviously not just in the Boston, corridor, but all around the world, go to the next level. They fatigued. They basically became, whatever, without getting into the depths of it. Meanwhile, all these other companies now with AI are kind of converging with the some of the better groups in academia, where they're effectively taking little bits of what they train. So basically the primary core and enabling research is where they stop. And then like a company like yourself runs with it, evolves it, trains it effectively, what they call transfer learning. So you initially have your initial, like imagine a baby starts from nowhere, you expose them to homes and objects and they learn basic things like this is a cup, whatever it happens to be. The AI starts very similarly, but grows very quickly. And it has a core set of capabilities. So in your instance, it would be how to optimally deliver audio and video packets for what is subjectively considered the best possible experience. Programming it would be a nightmare in terms of traditional classical programming, non-AI, because it's like a whole bunch of seals juggling balls on their nose type of thing at the same time. But that's exactly what AI excels at. So all of these overlapping but substantially independent variables changing at arbitrary rates in real time that have to be optimized for what we would call a qualified, successful experience from a usability standpoint. That, what I'm saying is the next stage of valuation and exploitation of that, if you so choose to, would be to license that for transfer learning in different verticals that don't compete with you, let's say, or don't affect you directly, or for inside corporations. Who knows, right? I'm just speaking mostly off the top of my head, but based on what is happening a lot of the time now.
Wow.
So it's kind of like you create your system to become your own little engine, your expert system to do what you need to do based on your unique infrastructure. Well, a lot of people have parallel, similar, but theoretically non-competing needs. So you may not want to license it to anybody in the sports, media, arena, but maybe whatever. Just a thought.
Well, I'm thinking like space and, other places where they need all those contingencies to have to be prepared for. And,
Yep.
I'm thinking that maybe somebody in those areas might do it. But if I were going to, as far as, a lot of the stuff is going to be, we're going to be catching audio and video coming out of the computers from Activision and the actual game that's being played.
Yep.
And, our challenge, I think, is going to be catching, there are like 9 or 10 different providers who are going to be doing that, right? They're League of Legends and all these guys. And they all have their own computers and their own packets and their own formats to catch. So we're going to have to do that. And then we're going to have to figure out what kind of phones people are going to use. And that's usually is going to be either an Android or an iPhone. and
Right.
then as they go, it's going to PCs, of course, and Macs are two separate things. But then again, they're going to be coming through a central game computer,
Yep.
and then in order they're going to be then figuring out how to get stuff out. And what I care about, what I'm hearing about, is that people are looking for a good answer for the phones. Okay, how do you get something onto an Android or a phone, an iPhone, that's going to be effectively better than what's available right now?
Yeah.
And I'm seeing that. I know that they're asking for it, and now we have to, I guess, deal with what the way the output is right now, and then be prepared to handle the I/O between the users on whatever device they're
Yep.
on. So,
Yep.
so what if, you're saying JW would be a good place to start, or like?
I would say I would definitely look into that. I'll give them a call back and tell them to follow up directly with you, because
Great.
that way there's no latency or whatever between the two. Sometimes it's hard to get in touch with me, so you just never know. I know you're reachable, and I know you're busy, but they'll definitely have no problem getting in touch with you.
I'll definitely talk to them. What about Wowza? Like, if I were going to set up a system right now, like, what would the stack look like? Would it be Azure? Where would you go if you were going to set up that infrastructure part right now?
Yeah, I started to put together a diagram, and I realized, because the last project I did in this area was about 2 years ago and change, right? And some of the componentry that is out there, there's new options. There may be better options. So I would say that it's something to give you a good idea. I mean, I could shoot off the top of my head, but the real answer would be, it just takes about a week of researching what those components are from the macro stack level, right?
Right.
Also, just an FYI, right now, PCs, Macs, and mobile devices are all different. They're starting to converge a bit, but the thing that's kept them substantially apart is CPU, GPU, and differences between them on each platform.
Right.
And something has happened over the past 3 or 4 years to a tremendous extent. And Apple was a little ahead of the game with their, various A-series processors, which they then bought the company recently and took it in-house. Everything's going ARM, and which is kind of like, if you look at a motherboard and you see what the ones from 2 years ago look like, and now you see the ones that Asus, Apple, and virtually all the mobile devices, they're all have these little chiclet looking things with rounded sides on them. And what they are is, you don't need $1 billion or $2 billion investment to go from a i7 to an i9 like Intel does, or similar huge freaking investments of AMD. Instead, what's happening is, you're talking about hundreds of thousands to a few $1 million. And all of a sudden, I can now, on my iPad Pro, I can do 4 streams of 8K and be editing between them. I can't do that on my Mac Pro. And the reason, and it's just, and with really not that optimized. I mean, I love DaVinci Resolve, and I've got it tricked out on my Mac Pro, balls to the walls, but it doesn't even compare, because the A14 chips and even the A12 chips are just so much more efficient. So laptops, because of power requirements and heat dissipation issues, have already started going there. Motherboards, because of performance benefits and because of time to market and cost to market for something which blows the doors off of what you can do with a traditional CPU. It's kind of like everything's becoming a blend between a CPU and a GPU,
Sure.
and they're becoming a very cost-effective and research dollars effective to be able to engineer. So from your standpoint, the thing that it's about to really start to do is that if you choose the right development tools and you take the right approach, you can substantially optimize across a multitude of platforms.
Right.
And there's a couple of Chinese and Taiwanese that are sort of fragmented, but with what's going on geopolitically, I think especially the Chinese one is going to be ostracized.
Yeah.
They're no longer having entree. So that's, I think, a good thing. because a lot of the back doors that were built into some of these things, I just don't even understand why Great Britain was like, I don't see a problem.
Yeah.
But,
No, way. It's fine.
Yeah.
That's stupid. That's crazy.
So anyway, you're going to be able to more and more do a monolithic, one size to a larger and larger extent fits all. Initially, yeah, you've got different end user bandwidth fluctuation differences. That's going to always be the case. But I think that should be something that from an AI standpoint, you start to optimize on. On the infrastructure, I had followed some of the stuff they were doing pretty closely about 3 years ago with some of the gaming platforms. We actually integrated to this was for storage, for long-term archival storage off of a gaming system where they wanted to have it so it was as close to real time as possible, but at the same time, not affect the core stream. And still to a large extent, they've, for the most part, they have used a lot of off-the-shelf stuff. So even the companies, the gaming companies that have kind of created some of their own stuff, it's more on the end user platform that the development has gone. So from a back-end infrastructure, you can make certain assumptions and they're not walled garden, or at least they weren't a few years ago. So that would be another thing to look into, whether you can make optimizations in that part of the delivery path.
All right. And to start, like generically, what cloud would you suggest?
And that's the other thing. I don't know if I assume that it's fairly widely discussed now. I don't know the details of when it's rolling out, but Google's next-gen platform is designed for multi-person interactive gameplay and media access. So unlike Amazon, which is a one-size-fits-all,
Right.
Google's really trying to position themselves for the Internet of Things meets, distributed gaming, multiplayer.
So I'm assuming then they have, if not active developers working on it right now, there's probably a way to get involved in that development process and watch them as it goes along. So whoever we tag for this is going to have that, be ready to work with Google on that. And hopefully they're known by Google or they know of Google.
Yeah, that's a very good point. Yeah, that's another side of it, is that companies that have relationships with existing, like I came on a bunch of projects over the years with Apple related stuff because I was very close to it for a bunch of years. And it's so much less delay if you already have people who are up to speed. So I'd say finding a Google maven, definitely, absolutely.
Cool. Okay.
And none of them are standing still. I mean, obviously.
Right.
But Google has
fast.
Yeah, and Google has pilfered. I mean, they took away so many of Apple's top AI people and infrastructure people. It's incredible. And Apple has deep enough pockets, but they didn't even see it coming, So Google is really in it for the long term for sure.
That's excellent. All right, cool. So I also am leaning toward the Google Cloud, the current one, because they have so many other technologies that we can lop on: the Google Translate, analytics, now AdWords and DFP and all the other things that they bought over the years. They sort of own, what we need to get done on the publishing and the website.
Yep.
So okay, that's cool, because then that would probably be less or more seamless as we go forward. So, okay, so we got to find that with those guys now.
Yeah.
Should I talk to JW for the player side and think about?
Yes, they probably have a lot of good input on a lot of things, I would think.
All right.
Like I said, I haven't spoken with them about this kind of stuff. I knew what they were doing. I know people that work with them. We used their player for years. I don't know how long, but when it was probably 5,000 lines of code, right?
Yes.
About when you started with them, I'm sure.
It was deep, yeah. It was really deep, and not fun to play with.
Yeah.
But, it was a flexible program even back then, and so I'll give them a call and see if we can find out, what they're doing on that cutting edge level of video for the game.
I have a cousin who works for Google. She's not a higher level right now, but she may know who to talk to. Might help me get in there and talk to somebody too.
Excellent.
That's great. Let's do that, Bill. Let's
Yeah, I know
see what
myself to do that. So hopefully we'll get some connections to find out what's going on with
great.
that.
Wonderful. All right. So hands-on, how would you like to? Oh, before I go there, actually, tell us a little bit about what you're doing, what you're planning on with the AI and the quantum computing and that kind of stuff. That's out on that bleeding edge thing.
Yeah, especially on the quantum side, it is fairly bleeding edge. Eric, who's a guy I've known for many years that I told you about, we will all get on the phone together at some point in the not too distant future. He is very good at IP, writing patents, getting patents through. He's got like a virtually flawless success rate. And he's got some, I mean, he uses attorneys and really good people that know their stuff. So he's been very good about that. I'm more on the tech side of it. So one of the things that's been sort of a match made in heaven, but two very different architectures, is quantum computing, where everything is what they call probabilistic and continuous function, so that the opposite is discrete and basically very deterministic, which is zeros and ones of classical computer. So all of the stuff that we've been using up to this point has been zeros and ones. And it's very much what we're kind of in the real world familiar with. Whether it's 0 through 9 or 0 and 1, it's either this or it's not. With quantum computing, the advantage, its innate power, is in the way that it is. So like I could create something with, let's just say, 100 qubits, which are like quantum bits. And I could have a bunch of 52 cards, faces down on a table. And I could guess, using quantum computing, the ace every time on the first attempt. And you say, how is that possible? And I won't get into the math of it, but effectively what it's kind of doing, and I know this sounds very metaphysical, but this is probably the most widely adopted explanation, which is not, I'm sure, not what it really is doing, but kind of the way when we banter about, is effectively, like when you have computers and you do something which is like, I got a bunch of possible choices to make. I go left, I go right, or whatever. There's a method called recursion, where effectively all it knows to do is make a left or make a right. And each one of them forks off and goes down its path, and you send another one out. With quantum computing, effectively, it can fork all of these in near zero time and do it in parallel. Now, some quantum physicists say effectively, it could very well be forking into a multiverse of possibilities, or maybe it's manifesting its own little, bubble in space-time and executing it. But whatever it's doing, effectively, it's outside of our delay space of space and time. So it seems to happen instantaneously. So the interesting thing was, the first time that a performance benchmark was translated, or actually a set of them, over to the quantum computing space. And they're very simplistic because they only had about 17 qubits to play with, right? Which is different than regular bits. So it's not like having 17 bits. It's like having 2 to the 17th bits. But effectively, there's a lot of errors. There's a lot of noise. There's a lot of garbage that you got to weed through to get your answer back. So it's not hyper efficient. But they did the benchmarks on these things, and Friday afternoon, they had them all tested, that they knew that they were actually gated properly, and they figured they'd let it benchmark over the weekend. So they effectively flipped the switch, and the guys who did the low-level math were different from the guys who did the implementation and so forth. So there was a little bit of break in communications along the way. So when they flipped the switch, it just flipped back. And they looked at the postmortem, and they didn't see any errors. So they did it several more times. And then one of the guys who's like looking through the pages said, it executed. And they're like, what? And when they looked at it, effectively, the only delays that they had that they could really see that were consistent was the data in and data read back. Sure. Everything else happened in near zero time. And some of the guys were like, yeah, of course. And the other guys were like, what? You know, it's like when you see it in real life, it's always like very different. So anyway, the barriers with quantum computing and real computing are that one of them's discrete and one of them's continuous. So how do you, like in the real world, what we do is we subsample. So we'll like, you know, like audio, we'll take 44,000 chops per second. Even though the waves are continuous, we approximate it. Once you do that with quantum, you destroy it. You effectively, you bias the output. Effectively, you disrupt it from being a quantum event. So that doesn't work. So what you can do is work with, in our real world, the analog of a multivariate space, which we created the math for what that would look like. And it's kind of, it's not as obscure as it sounds, but it's basically an 8-dimensional architecture where there's certain things that are rotation based, certain things that are index based, rotations being continuous, indexes being discrete. And as they line up, resonances are set up, which can be evaluated on either side. So you can effectively, that becomes the bridge. We call it Q-bridge. Now, why would you want to bring the two of them together? Well, it's kind of like one is really good at a certain set of things, and the other is really good at another. We interface really nicely with classical computers, non-quantum.
Sure.
Quantum computers, they're able to do what are effectively, especially when you look at like D-Wave, which is the one that we initially optimized for, all that does is what they call adiabatic, or basically lowest energy state. All it does is optimization problem solving, which is like if you wanted to solve for like a bunch of UPS trucks delivering X number of packages to X number of houses. Without quantum computers, at about 7 trucks and 15 packages, you're beyond what traditional supercomputers could ever handle in our lifespan. All you could ever say is, oh, okay, this answer is better than the one we had yesterday. But you can't, if you looked at it as a bunch of possible ups and downs in the 3-dimensional space of what, you know, phase space, what solution is the best, you couldn't see, oh, there's the lowest low, or there's the highest high. Quantum computing effectively is like stepping back from that whole system and saying, oh, there's the card, there's the lowest. So bridging the two of them, in most of the problems that we can't readily solve are most of the real world problems that we have. Weather patterns, package delivery, energy utilization. So it'd be great if we could adapt AI, which, by the way, everything in AI happens to be, by its definition, an optimization problem. How we actually train an AI model to be optimal is by a series of washing back and forth a whole bunch of calculations, billions of times, till we get the weights and the connections between the artificial neurons in a particular state that it becomes really good at whatever. Just like our brains, kind of, you know. We say with our brains, neurons that fire together, wire together. It's kind of like that. So bringing the two of them together, you have something that needs optimization solution space capabilities, and one that's all it can do. So that's why we've brought them together. And a lot of others are working on it. IBM is doing, will have a different path to a solution. We just happen to be among the first. I don't know, in military, they might have already solved it 3 years ago, but we'll never know.
Right. Wow. That's cool.
Yep.
So when is that going to become like something that we can actually access? I mean,
we're actually, this year, we have a series of projects that we initially did our basically proof of concept or MVP, whatever you want to call it, version using traditional AI. And that's like the golf swing thing, the, you know, some of the things related to wealth management, you know, financial stuff or whatever, that we're now just bringing together with AI. And we set up a what we call basically a quantum AI lab, which we're just bringing in partners from both projects and a funding standpoint, so that we have a good mix of real world things. We have about 5 projects of our own that we're porting over, and we want to have a few others in non-military and all traditional corporate type of stuff in education that we work with. And hopefully over the next 12 to 18 months, we'll have at least 3 of those. That's our game plan.
wow. And okay,
with any
so
luck.
that's incredible. That'd be really cool. So when do you think there's actually going to be real quantum computers?
You know, the funny thing is, it's like, you see what happened with AI, that a couple of years ago, it all started to break loose.
Yeah.
There was a couple things that happened. Google with TensorFlow, they released it for free, one of the best tool sets, but also a terabyte plus of training data, which normally that's real time and cost intensive. So all of that was pushed out for free. NVIDIA with their GPUs created CUDA cores, which were general purpose. So you didn't have to have a $750,000, you know, TPU, tensor processing unit, like a Silicon Graphics of the AI world, which that had been around for a while. So a lot, you know, in high finance, like Wall Street and
Right.
big pharma, they used AI successfully for almost a decade before that, but it became mainstream. That's kind of what's happening now with quantum computing. Quantum computing is actually real in that it has solved, for certain limited applications, some very data intensive problems. About a year and a half ago, this got out. It was part of one of the illegal dumps. I forgot who did it, but we have, you know, Prism, you know, our underground collection vaults of, where they go through supposedly only the subject line of all of our emails and only at-risk communication, whatever. Somehow there's 17 levels of firewalls were breached for 59 seconds in parallel, laid bare, to the point where anything with firmware in it, anything with the ability to store a hard drive, all had to be shredded, thrown out, because they didn't know what might have been left as a ghosted image or actual bits. So they, you know, billions and billions of dollars of hardware got scrapped. And whether it was our own country testing our infrastructure and they just weren't told, or whether it was China, which I don't know any other player that could readily do it, but who knows? Somebody had that capability. And the only thing I know that could do that, unless they've solved in a canonical form how to like get around, you know, AES and related encryption, which is theoretically possible. It's not very likely because you're looking at the factoring of two big freaking prime numbers. Quantum computing had to have been real about 18 months ago for a real world problem that was pretty big. So they, you know, a country can afford $500 billion for something like that. And there's only a couple of them, but we would be one of them. China might be another, right? The only other thing that I can see is that in the areas of a lot of smaller problems, it is also real for sure for a lot of companies. Now, general purpose AI and general purpose, readily accessible with a high level interface where you don't have to understand what a quantum gate is to program it, that is about 3 or 4 years away. But for the rest of the, how would you say, high-end needs and ROI that can justify it, it's here now to a limited extent. And it's growing 100-fold per year as opposed to doubling every 12 to 18 months. So it's, you know,
Frank.
And there's a lot of clever stuff that has to be solved. If they do that, all of a sudden we'll see a leapfrog of capabilities. Right now, it's like you can't just throw more qubits at it because the noise, it's kind of like you can't just turn up an amplifier higher and higher because the noise starts to overwhelm it. Same thing with quantum. So they have to figure out a better way of error correction and avoidance than just adding more qubits to it.
Cool. Excellent. All right.
Aren't you sorry you asked?
No, I'm so psyched. You kidding? I'm gonna go back and listen to the video like 100 times to get all the shit you're talking about there. No, that's actually the answer I was expecting was around there.
Okay, good.
So yeah, I've also been watching the stuff, and it's just amazing how it's developing. You know, have you been watching? Have you watched that series called Devs?
Yeah.
It's
that
all
was
about
great.
this determinism and all this kind of stuff. It was amazing. It was really incredible.
You know, and for the most part, man, they researched the hell out of it. They did a good job.
I only imagine. They were really like there was, you know, it was cutting edge. It was all right there.
Yeah.
It was amazing. Okay, so takeaways from our conversation. One, we should talk to Google and see if they've got known people who we should be talking to work with us.
Yep.
should I be talking to some of the colleges, universities that are in this, or?
Yeah, it's really the variable part of the universities is that you really need to interface with somebody who is a mid-range grad student and be able to have him on the team. Because unfortunately, a lot of the people that they wind up putting on a lot of projects that are not long-term they're gone 6 months, a year. And that becomes problematic. Just like in hospitals, most of the errors and problems happen between change of shifts, same sort of thing. So you really need continuity, and they have to be able to, however they can do it, guarantee that, whoever it is.
So universities, you think like the usual MIT, Stanford?
Yeah, it depends on who you have ready access to and who has availability for the types of projects. Because periods of time, it may be a year wait before they have people that are like up to what your needs are, or that have specific. A lot of times they'll just say, oh yeah, of course we've done that. But you never get the people that are actually done that. You get new students,
Right.
So you got to you got to ask them and know what to ask to make sure that they don't just take something on.
So,
but yes, they can be great.
So is that new Google Cloud already out, or is that something that?
No, I don't think it is out. I'm no longer actively very deep in Google development, so I don't know what has been released with the latest toolkits, but it is coming out, or it was supposed to come out this year. So at least that's the last thing I heard. And maybe they'll do it in phases.
Okay. And so I have liked the Google Cloud all along because of all those other side benefits. So I think by leaning on them, maybe they'll be able to, give us a hint as to when the new stuff's coming out.
And they do like to be able to have a real world rubber meets the road partner that can actually try the stuff out, to a limited proof of concepts. They'll bend over backwards to give you added resources for that.
Anyone, any idea what department, division, or anything I should talk to over there in Google? You gonna research it and figure it out?
Yeah, I can give it a little bit of a shot and see. They kind of wind up directing you whatever way they direct you. At least that's my limited experience with Google. Like I said, I haven't been deep with Google, not for a while anyway. And even then it wasn't deep.
Right. Okay, so yeah, what iPad are you, the iPad Pro, is that the new one, the 4th generation?
Yeah, I normally, I had a 2017 up to when I just got this 2020, and I got it because of the AR, the LiDAR capabilities.
Right.
And I love the new keyboard that they finally just came out with.
The Magic Keyboard?
It's great. I mean, it's a ripoff like most of the stuff, but it's great for what it is. And I was so happy when the version 13 of their operating system came out, and you could readily share files and everything back and forth. It's a godsend.
And that chip, the A12Z, is that what it is? That's right there, right? That's cutting edge.
Yeah, it's, a little bit of marketing. They kind of overclocked the old one. That's why they didn't call it an A13 or 14 or whatever. But it's freaking amazing. I mean, like I said, I've got a Quad Titan X GPU-based Mac Pro out there, right? And this thing kicks its butt on 4K and above.
Wow, that's incredible. Amazing. All right, so, and takeaway, other than that, talk to JW, see what they're doing on that. Now, is that mostly for PCs and Macs, or is that also for the phones?
They do mobile as well. I'm not sure if they are the best game in town for mobile or not. At one point, they were ubiquitous. So,
right. Of course.
And the only reason why I say it might be worthwhile speaking to them is they did a fair amount of customization work for a while. Mm-hmm. So if they're still doing it, if they're still open to it, they understand all of the things. And I mean, it's not just with their player either. So they've had to solve the same problems that any player does.
Yeah, okay. That's cool. What other questions should I be asking? I think that's about where we should be right now, right? And then work out where we go. But what I want to do is make sure that we have a commitment that I can go back to the video game people and say, we're committed to be this cutting edge provider. And How much do you think it's going to cost us to put something together that's going to work on all 4 general devices?
You know, it's a matter of how you decide to phase it and stage it, right? So that becomes, I'm a big believer, because I've had to be on both sides. I've been both a consultant and I've had my own companies. So I believe in bringing both ends and seeing how you can best put them together. So you have a time to market requirement and a cost overhead, potentially. It depends on the market, right? Anything with AI, it's so much easier to get freaking big number funding. The ratios are so much different and whatever. Especially if you intersect with gaming or medicine, or, you know, like big pharma or whatever. So anyway, that short of that type of a thing, basically tying both ends and saying, look, and this is what we can do from a tech standpoint within those constraints. That's kind of the way you may want to approach it. Because your resources will tell you what are the viable approaches. You may want to re-engineer portions of the stack, and you say, you know what? Okay, that would add 3 months to it and cost an extra 150,000. It doesn't make sense. Or maybe it does, and maybe you can just throw additional resources at this. But you know, you're talking about something where you can hit the market running with bringing at least one solid person in-house on the tech side and a couple of business people for less than $2 million. You know, I mean, you can definitely hit that market. Now, depending upon how different you want to be from the rest of the marketplace and what your time to market requirements are, you can shift that around. I mean, there's some people that hit these things for a couple 100,000, and it's, you know, and they're doing good business, hitting the ground running. You've already been in that, you know, place, you know what that is like. And then there's people who, you know, spend ridiculous amounts and don't get anything more out of it. And some people that hit the ground running with big budgets and do a great job.
Wow.
So you can do it any which way. It's a business decision.
I'm getting the feeling that we're going to need like 3 different time frames. We're going to need something for the short term for, you know, for the 3, we're planning on launching the MVP for the site and the apps between 90 and 100 days after we have funded. And that's
Gotcha.
what I'm hearing from our developers. But so obviously we're gonna need something that's solid, that will come out of the box working. But
Yep.
It looks like after that, we're going to start thinking like a year and a half down the road, like this is the next level. And then, you know, when you guys are ready to use us for the test bed for the quantum and AI stuff, that's going to,
Yep.
3 years, 4 years down the road?
Oh, well, it'll be before that. We actually are probably going to sell out the company within 3 years.
Oh, wow. Cool.
Yeah. Yeah, we have groups that we could bring in to kind of like, but they would own us from the get-go.
Yeah.
And the ratios aren't very good. And, you know, you're better off waiting as long as you possibly can.
Yeah. Yeah, we're thinking the same thing. We could do the same thing. We start moving things out in 2 or 3 years, but I'm thinking 5, 6 years.
Yeah.
So, okay. So that's very cool. Yeah. So.
And the only thing about it is with the quantum, that will change when you start going quantum, and everybody's going to. We will all be involved with this in our lives. We're all very accustomed to Moore's law, right? And Moore's law is, I mean, it's predictable, but, you know, so we've seen a 1,000,000-fold increase since the late 70s. That's about right where we're at. You know, the cost per every megabyte, gigabyte, whatever, the processing ratio, speed differential, and all of that. Imagine, and I remember the first time I did this with quantum computing, this was about two and a half years ago. I said, oh man, 100-fold per year. It's a double exponent, right? I'm like, all right, so 10 years. And I put it into my HP41C and it overflowed, right? I'm like, oh, yeah, okay, all right. So I put it in 5 years and I got 750 billion in 5 years. That's, you know, that's like 7,500 times more in the next 5 years than we've seen in the past 44 years.
Yeah.
And then when you add the ability to not have to program because of AI, but rather just apply data, and at the speed of electrons, it will advance the concepts that we saw at Terminator and all the other crazy stuff doesn't seem so ridiculous.
No.
Thankfully, it won't really happen in our lives, but it won't be long after.
Wow. That's incredible. All right, man. What are we forgetting to ask? What else do we need to know?
There's a lot of things. It's really, the devil's in the details.
Right.
I think a very important thing is to get a really good game plan. That's your, whatever the critical threshold is to market, 90 days, whatever that is, say, look, this is what gets us there. Because you may find that if you say, you know what, we could actually get to market in 60 days, and we would have this, and then we haven't integrated this part of it, which means that we don't have to redevelop something, throw it away, and we haven't wasted 30 days. You know what I mean? There's a lot of things. And then also you can position yourself better for the bigger money raises with more efficiency. Because once you have realistic blue sky that you can start to demo within your architecture, the world's much more your oyster.
Wow. That's awesome, man. All right, cool. Andrew, I can't thank you enough for all this help. This is really great.
Always great hanging, man. And I love speaking with you. And
Same
we'll follow up, and we'll have Eric, and we'll have a little conversation at some point in the near future.
Awesome. Look forward to it.
Nice to meet you, other guys.
I'll see you too. You take care of yourself, Andrew.
Likewise, Andrew. Thank you.
Bye-bye.
Talk to you later.
Bye-bye.
Take care, guys.
Peace, guys.